everyone, thank you so much for joining. Thank you both here in Zoom and on Twitch. Real quick, I will say, because I know people are coming in on Twitch. I apologize for my lack of streaming recently. This project that I've been trying to kick off has really kind of taken a life of its own. But it's been a lot of fun. Been doing a lot of interesting stuff. I will say I will be streaming tomorrow night, but it'll be a little bit later than my normal time. And that's because my daughter, she's having her graduate recital that starts at 7:00, and I'm not missing that. So I'll be in after the recital. All right. But let's talk about a little bit on that. So real quick, I want to thank our sponsors. In particular, Modus and Tech Systems has been longtime sponsors of Louisville.net. And then, we get help from the .NET Foundation, to include some folks watching this session right now could very well be coming in from the .NET Foundation, because they do list us to help publicize these meetups. All right. I actually do have meetup scheduled. Actually, sure enough, the May 20th, I got it in the meetup site earlier today. But so May 20th, we will have Ed Charbonneau talking about Blazor. So that'll be, if you don't know Ed, Ed has dedicated his life to Blazor essentially. And actually, he did it early on, so he's been blazing the way on Blazor, pun intended there. And then June 17th is scheduled. I just don't have all the details set yet, but basically it is going to be a presentation about Fiddler, all right, and how you can use Fiddler to work with your web and internet type resources. So should have that lined up here probably in the next week. And then so those are upcoming meetups. As I mentioned, .NET Foundation asked us to add this slide in here, but I'm more than happy to add this in here. You can definitely check out the .NET Foundation virtual user group. Always great, bunch of great meetups happening almost every day. And it's one of the great things that came out of the pandemic was supporting this. I remember when this came up, right? And it was really good to see the .NET Foundation do this. I already talked about TaleLearCode. So like I say, normally Monday, Wednesday, Friday, I'm streaming on there. Copalooza. So Copalooza, I had to make a decision back in December, which is why it's definitely online. But there's some good things with that. So Copalooza will be online this year, August 18th and 20th. Tickets are available right now. And if you have any interest in speaking, our call for speakers is open right now. And especially if you're a first-time speaker, definitely think about it, right? And and don't think like you have to go into it all new if you've never spoken somewhere before. Reach out, and we'll get you connected with someone who could talk you through even just getting the proposal written, right? And then if you get selected, we'll help you with how do you present for your first time and everything. So definitely, like I say, give us some thought. All right, and sure enough, if you haven't been here, normally we would be going to BJ's restaurant afterwards, but we can't do that. So sure enough, after the meetup, we'll disconnect from Twitch, but we'll stay here on Zoom and just chill and socialize, and really for as long as folks want to, right? And we'll keep the conversation going. All right, so that ends my slide. So quickly, I want to introduce Jared. I mean, I'll let Jared actually introduce himself, but to introduce, this topic, this actually was interesting. This actually is based upon an email that was sent in the MVP email list. So, MVP is Microsoft Most Valuable Professional, and basically it's Microsoft's way of recognizing people who give back to the community, who do stuff like I do, speak at events, run events, write content, all that type of stuff, do Twitch and so forth. And one of the benefits we have is, we have a bunch of email lists that we can, questions about the products or perfect example. I found a bug in API management. Sunday that is preventing me from getting something done, I actually sent an email. It's like, hey, maybe I'm doing something wrong. And no, I actually found a bug and actually hurry have it fixed, right? Which is just really awesome to see it. But there was actually an email asking, hey, all this stuff is getting added to C#. What is the C# team doing to make sure that we don't kill the language that we all love so much? And sure enough, the C# team, they did a what they call a product group interaction, which is a meeting with MVPs and the product teams. And this was the topic, right? And I reached out to Jared afterwards. I'm like, hey, that was a really great session. I really enjoyed it, really learned a lot. And is there possible to do a non-NDA one for Louisville.net? Hence, that's why we're here tonight. So with that, I will turn it over to Jared.
All right. Do I need to do anything to get my slides back on, or?
You just have to start sharing again.
Just sharing again? All right. Yes. All right. Let's do, there we go. That looks like the right one. There we go. All right. Well, Chad did a great job of kind of like, getting to the introducing this topic. So this is basically a presentation on kind of the C# language design process. As he said, there was kind of an email thread where a bunch of the MVPs had said, like, over the last 3 releases, kind of if you look back from C#7 all the way through C#9, we've gotten through like tuples, pattern matching, nullable reference types. We've added a whole bunch of features. And some of the question was basically, it's like, are you adding too much? Like, how are you kind of being responsible? Are you all just like, kids in a playground where you're just adding features nonstop for no reasons whatsoever? And so we kind of took that feedback to heart. And as Chad said, this is a presentation we kind of gave in response to that, where it was basically kind of an explanation of like, hey, let's kind of open up, the door a little bit and show you all, how does the C# language team actually, what is our design process? How do we pick these features? Like, what do we do to kind of like sort through all of the things that we may want to do and come out with kind of a coherent language release on the other side? And in doing so, we hope it kind of gives some context into like why we've chosen the features we've done, why the releases have been structured the way they are, and hopefully give you a little bit of insight about how future releases are going to work. So let me see, can I get the focus? Yeah. So a little bit about myself. So I am Jared Parsons. So I am the C# compiler lead. I am also a member of the C# language design team. I've actually been working on the .NET languages teams for about 15 years now. I've done pretty much everything you can do in the languages. I've worked on the IDE experience. I've wrote some of the debuggers back in the day. I've done a little bit of research. But for about the last 7 years, I've been the C# compiler lead, kind of starting with about C#6, and a member of the C# language design team from that time. And I'm really happy to be presenting to the Louisville.net meetup. I am actually from Louisville. I was born in Crestwood, and I lived there till about 2nd grade, and I still have a lot of strong family ties to the Kentucky area. So really happy to be presenting to you all today. And so, as I said, the purpose of this talk is to make sure you know that these are not compiler bugs that you see, but really it's to kind of demystify the language design experience. And so I want to kind of give you all a peek in like, how do we get ideas? Like, how do we go through the design process? And then kind of, what do we do to prioritize these things? Like, how do we look at this like set of features in front of us and say that, well, we have a limited set of resources. Like, we're going to pick these 3 and kind of put these 2 to the side for a while. So the first one to kind of talk about is like, where do we get our ideas from? Like, how do we pick these features that we're going to add to the language? So for me, at least, ever since I've been a member of the team, whenever I think about features and releases, I always think about kind of these 3 different buckets that all of our features kind of end up going into. And they're really like kind of productivity enhancements, performance improvements, and what I'll call like kind of division or company initiatives. So as I said, pretty much all the features we do, they end up fitting into these buckets, and these buckets end up kind of forming our releases. So productivity enhancements, these are the type of features that you will use, which are essentially, they kind of reduce the boilerplate code that you have to write. or they provide kind of a declarative experience for common patterns that we've seen in people's codes. So some examples of this along kind of the years would be like LINQ, like language integrated query, where you could essentially look at all of these like nested for loops that people were writing and all these kind of like conditionals to build new lists, and we gave them instead SQL query essentially experience. Or async await, where once we kind of introduced the parallel task framework to .NET, you had all these people doing like task.continue with, you had all of these lambdas within lambdas within lambdas that got like impossible to read. And in response, we added async and await to the language, which let people have that same type of parallel experience, but with just much more declarative syntax. It was all about helping the productivity of the programmer. And kind of more recently, we've had things like source generators that just came out in a recent release, which is also going to hopefully help a lot of productivity by kind of allowing the libraries and tools to generate a lot of that code for you. So historically, the ideas for these type of features, they actually come from the C# language design team. And what we do is, I mean, we honestly, like we spend a lot of times, we look at competing languages. We kind of see like, what is Java doing? What is F# doing? Like, what is Go or Rust doing? And just saying like, they're doing good things too. Or do they have good ideas that we could kind of bring back and incorporate into C# to make it better? And we also spend a lot of time looking at our partners and customers and like, what problems are you facing? The MVPs, as Chad mentioned, is a list that we talk to frequently. They come to campus once a year before COVID, and we spend a lot of time talking with them like, hey, what's going right? Where are you struggling? And they're very open with like, hey, these are the corners we pace ourselves into. And MVPs are often good enough that they will come to us and say like, we hit this corner in the language, but we noticed that in other languages, they don't hit this corner because they have, this feature or that feature that you guys could think about incorporating. And we also spend a decent amount of time looking at research papers. There are plenty of like research papers written on programming languages, and they often have some very good ideas that are single focus that usually require a bit of refinement before you can put them in a production language, but they're excellent sources for ideas. But lately, the C# team, we moved all of our code to GitHub about 5 years ago. And since then, we've actually been starting to get a lot more kind of community interest in their productivity enhancement side. We've had smaller proposals, things like the target type new feature was really kind of the community-driven proposal and implementation. And then we've had bigger ideas like kind of shapes, if anyone has been on kind of the language design repo, you've probably seen that one. It's one of our most active discussion topics. And while things like shapes will probably not directly make it into the language, there are other features that we are looking at roles which are heavily influenced by those community proposals and discussions. So kind of the next bucket of features is performance improvements. So these are kind of features that allow developers to improve the performance characteristics of the code they're writing. Generally, it comes down to a couple of, familiar patterns, like features that help remove heap allocations so that they can reduce the amount of GCs they have to run, things that remove a lot of unnecessary struct copies. Struct copies, if you get to really high performance C# code, struct copies are kind of like the thing that they end up focusing on the most once they get past heap allocations. And also kind of removing interrupt overhead. A lot of low level programs end up having to talk with some C libraries or get deep into the runtime. And the overhead for interrupt actually starts to matter a lot there. And anything we can do to kind of alleviate that can really help the overall performance of the language and framework. Some examples of the things we've done in this area over the years are things like ref returns, ref structs, and span of T. We've also added read-only structs and members. Those are really helpful for alleviating struct copies. And even most recently, we added function pointers into the language. Now, these types of improvements to the language, these are generally driven by our partner and high impact customers, because these are the type of customers who will come to us and say like, hey, we measure perf a lot, and here are the problems we are hitting. And they are also very educated, and they tend to send us like very good data and will basically say like, hey, other languages don't hit this problem because they can avoid this type of copy that you all force us into. And the really interesting thing about kind of performance improvements is this is one feature where the language design team has made decisions over the years, but customers have come back to us with better data, and it's actually caused us to change our mind on what we would and would not do in the language. And function pointers is a fantastic example of that. This is shipping largely in part because of the Bing team. So the Bing team, we'd said no to function pointers for many years. And then kind of the, actually go this way, I forgot. So the history of kind of function pointers in the language is, the goal of function pointers is to really get this IL instruction called call to be used from C#. So if you have ever actually looked at, if you've ever decompiled your code and looked at the IL, you'll see there are lots of call and call vert instructions. And that's how methods are invoked. There's actually a third instruction called call and it's really useful if you're doing like low-level interop code or if you're working with basically pointers. And there have been design attempts to get this into the language that go way back to the native compiler, so 10 plus years ago. I think there have been about 3 different implementations over the years that people tried to give to us and that the language design team ended up rejecting. They kind of said like, yes, you know, that's an interesting feature. It can reduce performance, but it's a pretty niche scenario, and it just doesn't meet that bar for adding complexity to the language. Yes, you made things better, but you haven't gone over that hump. You haven't gone over that hump of making things so much better that it was worth adding a new concept into the language. Then came along the Bing team. So the Bing team actually forked our compiler. They implemented one of the proposals we had out there for call. They pushed it through their code base, and they presented the data to us. And one thing that is amazing about the Bing team is they have amazing data. They take very regular drops of the .NET framework and the compilers, and they will tell us like they are one of our best regression scenarios. They'll come back to us and say, hey, we took like another daily drop and like our page, you know, latency went up this many like milliseconds. And it's just like, oh my God, like, you know, you guys have such great data. But when they pushed this function pointer code through their code base, they kind of came back, they presented the data to us, and it was super compelling. Literally, like they gave the presentation and the speaker McCool, like I basically like grabbed him after the meeting and we went back to my office and started kind of hashing out some of the details with them. And kind of, it was overnight. We had this conversation that had gone from like, you know, should we ever do function pointers? Probably not, to, okay, we're definitely doing them. Like, how do we get this thing into the language? And like some of you might be sitting here thinking like, you know, function pointer, like seriously, like that feature we had in C, like they're going to put that into C#? Like, you know, why are they doing this? Like, why would you ever do something that low level in C#? And this kind of gets to our motivations. Like function pointers is something that will probably never be used by the majority of C# programmers out there. In fact, like if more than 1% of C# programmers ever use this feature, it would actually be quite surprising to me. At the same time, the small percentage of people who use that feature tend to be the ones who write the low-level libraries and frameworks that power the .NET ecosystem. Like for instance, the runtime team, the .NET runtime team, like they really wanted function pointers because it allowed them to heavily optimize some of the low-level interop they do between kind of the managed and native boundaries. And because that code, it runs in all of your application. Like if you kind of step back and think about any application you've shipped, whether it be like an ASP.NET application, a WinForms application, or any kind of like Silverlight or line of business application, I mean, there are millions and millions of lines of code that go into that application. I mean, if you look at like the .NET runtime repo on GitHub, it's about 5 million lines of code today. And so these high performance like features, even though they can often only be used by the 1%, but like kind of this like 1% of C# users, it tends to be the 1% of users who write code that runs in 99% of the application. So it turns out like giving them the tools to make their code faster and more efficient has this kind of magnification effect on the ecosystem, because it ends up making all of the other programs and frameworks run faster too. And so it was a real kind of turning point for us in C#7, where we started giving like these low-level features like ref structs and span to some of those 1% developers, and they were able to dramatically increase the performance of the .NET framework and ecosystem. And so we've been like more aggressive with that in later releases to really kind of push the envelope there with performance. So the last kind of like section, kind of bucket of features is what I'll call like division or company initiatives. Like we work for Microsoft. Microsoft has interesting goals. Sometimes we have business things that we need to achieve. Like most recently, like we bought Xamarin. And if you're not familiar with Xamarin, they write kind of like a very excellent like cross-platform programming toolkit. It works across Android and Apple. And in order for them to be successful, they have to be able to adapt all of kind of the code you write in C# onto these Java APIs that they end up running against. And they were really getting hurt because they didn't have things like default interface methods, which is what the Java APIs used heavily in kind of the Android scenarios. If you go back to about C#, I think 2 or 3, I can't remember which, Office programming was something that Microsoft was really invested in, like making it easier to write plugins for Word and PowerPoint and what have you. And we came out with Dynamic as a response to making COM programming a more palatable thing for C# developers. More recently, we added indexes and range into the language because it helped a lot with giving kind of machine learning code a more Python feel in .NET. And these are basically cases where C# kind of needs to adapt. We have to ensure the broader goals of the company are being served, and we add features to the language to make that happen. And occasionally, like, these features can get a bad rap. Like, something I'll hear a lot when I'm on Twitter, people are like, oh, I wish we could rip Dynamic out of the language. It was a huge mistake. We never should have added it. And it's like, Dynamic is an incredibly successful feature. I know because I get the bug reports when we break it. So I know that it's something that, like, while we added it primarily as a means to kind of solve this Office programmability problem, we were very mindful to make it a general feature. It has been extremely successful. It is still, we are 10 plus years past adding it, and customers are still readily using it. And even as they move from .NET Framework to .NET Core, they are continuing to take Dynamic with them. Once again, I know this because of the bugs we had, that we did not port code correctly from Framework to .NET Core in kind of the DLR space, and we had to fix that for a lot of customers. So, but kind of the next step though is kind of, once you understand like these kind of big buckets that we put our features in, kind of want to talk to you a little bit about like, how do we actually design? Like, how do we go through the language design process in C#? So C# design, it occurs in a number of venues. So we have a regular C# language design meeting. We have an email alias where we hash things out. We also spend more recently, kind of ever increasing over the last 5 years, spending a lot of time doing design in the open with the community on the C# language repo, so .NET C# Lang. We push all of our proposals there. We have started using issues and GitHub discussions to kind of interact with the community. And even more recently, we've had a lot more discussion on Discord. There is a C# Discord server out there. It has a lot of active involvement. There is a really good mix of people who are on the C# language design team, as well as kind of some of our more advanced community members, as well as some new people who just have ideas. And there's been a lot of really good discussion there about how the language should work, how we can move it forward, and how we could change things. And, occasionally we design on Twitter. Not proud of it, but it's fun to do sometimes. So the C# meeting process. So how do the LDN meetings work? So C# language design, we meet about twice a week, Monday and Wednesday, about 2 hours. And then every quarter, we have what we kind of do, a review with the C# design alums. C# has been around for about 20 years now. A lot of people have come through the language team through the years. People who've kind of moved on, they still have valuable opinions. And so kind of once a quarter, we meet with them and we say like, hey, here are the ideas we have. Here are the directions we're thinking of going in the next release. Like, give us your feedback. In particular, maybe we're stuck on a few points and we want to get kind of Anders or someone else to kind of give us their kind of take on which direction to go with some decisions. And so we broadcast the meeting agenda about a week in advance. Everything is done on Teams now. We open the Teams meeting to all Microsoft full-time employees. Only the C# team members are muted by default, but we get pretty good participation in kind of the side chat where people will just be chatting about in text about what we're discussing. And at the conclusion of every meeting, we post the notes from our meetings onto .NET C# Lang. Usually within about 24 or 48 hours after the meeting, you'll get some nice little notes up there. So the meeting format kind of depends a little bit on what we're doing, but generally it's the primary reason for the meeting is discussing proposals. So basically we'll have a proposal that we're talking about. Like this week, we were talking about how to make interpolated string formatting significantly faster, as well as we had some open issues on record structs and some improvements we're making to Lambda expressions. But generally, they kind of start with proposals. So we have a lot of discussion about like, how does this proposal fit with this existing C# features? Like, is this something that's new and crazy that it's like a huge concept count that we have to add to the community? Or is this kind of an incremental change? So for instance, like in C#10, there are a lot of extensions we're looking to do to pattern matching. We're looking to make it easier to dot through patterns, maybe to add list comprehensions to patterns. That's kind of an evolution of an existing feature. It's not a giant concept count. Like when we introduced pattern matching at the start, that was a big concept count to add to the language. But is this kind of an evolution of the existing pattern? A little bit lower concept count, like a little bit, it doesn't have as big of a bar to clear to get into the language. But we talk a lot about, kind of critical discussions like, hey, yeah, you have this proposal here and it absolutely solves a problem, but could we solve that problem with other ideas? I mean, are there other things in the language that exist today that kind of almost solve that problem and we would maybe be better served by making kind of a small tweak to an existing feature as opposed to adding an entire new concept into the language? And we also spend a lot of time talking about like, does this create future traps for the language? Like, okay, if we take this feature in, we are essentially reserving a new keyword. Like, did we want to use that keyword for something else? Like we've had a lot of discussions when we were doing pattern matching. We started looking about like, should we reserve the match keyword? There were a lot of things that wanted to kind of take over these keywords, and we were kind of saying, we know we're going to do pattern matching in the future. We think we very much might use match, we might use win, we might use all these other words. And we kind of pushed on the proposal saying, we don't want to take this because that creates a future trap for when we do pattern matching. Other type of future traps we worry about is features that would impact overload resolution. That's always fun. So actually, that's one of the biggest discussions we have is whenever a feature impacts overload resolution. Overload resolution, for those who don't know, when you call a method in C#, like if you do console.writeLine, there is not one console.writeLine out there. I think there are something like 40 or 50 console.writeLine methods. And depending on which argument you pass to it, the language has to pick one of them to call. And the process by which we look at the arguments and we look at all of the potential candidates and pick one is called overload resolution. It is one of the most complicated parts of the C# language. If anyone whose name was not Neil Gafter or Eric Lippert ever told you that they completely understood overload resolution, you can have sure bet that they're probably lying to you or sorely mistaken. It is one of the few features in the language that actually, if we ever change overload resolution, one of the kind of pull request sign-offs is all of the senior members of the compiler team have to sign off on the change because we're all going to have to own it later. It is an absolutely crazy part of the language, but it's something we talk a lot about of like, will this impact overload resolution? And how do we deal with it if it does? So the other thing we do in language design is we review feature issues. So generally after LDM accepts a proposal, developers go off and work. And no design is perfect. As developers are kind of implementing code, they find lots of cases that we didn't address in the initial design discussions, like lots of small decisions we need to make. And we don't want to have this like really rigorous model where every time the developer hits kind of an open, like an kind of an uncertain point in the spec that he has to go back to LDM and ask a question and wait for a decision. Instead, we tell the developers when we hit those kind of problems, make decisions. Like think about what the best idea would be here, think about what the most likely outcome is and start coding, but we write it down. We kind of have a note in all the pull requests like, hey, ran into this question, we're going to review it later. And so generally when we get kind of the end of implementing a feature, we go back to the language design team and we say, hey, here are all the small decisions we had to make while kind of implementing this feature. Do you want to push back on any of them? Do you want to kind of like tell us that we made the wrong decision? We also spend a lot of time talking about proposals that are on C# Lang. So people file proposals all the time on the kind of GitHub alias. And we spend a lot of time kind of going through them saying like, do we want to actually do this? Do we want to like look further? Do we want to get like a good design for this? So that's it. All features begin on C# Lang. Anyone can file an issue. And honestly, we like to leave the issues open to encourage discussion. Like even when we look at a feature and we're like, probably not going to do that. That seems somewhat unlikely. We like to leave it open because we want to encourage people to explore the ideas. Because even when we look at an idea and we're like, probably not going to do that, there's often really good discussion on either why people wanted that, which may encourage us to do other features, because if we see common themes in these discussions, common problems people are facing, that might push us to say we should invest in solving that problem a different way. Often though, sometimes customers on their own actually have a really good discussion. They kind of end up moving past the design we didn't like and circling into something that's a little more palatable for the language. Really, the only time we close issues is when they have like zero chance of being implemented in the language. When we just want to we're like, there's no way this is happening. It's not a problem we're interested in solving. If you want to talk about it, like that's fine, but we should keep this website more for talking about things that have kind of a chance of going through the language design process. So while anyone can open an issue, in order for the issue to make it to a language design meeting, you have to have someone from the language design team kind of champion the issue, basically say, this is worth taking in the meeting. This is worth kind of talking to the broader team about. And we do that by adding this, really fancy thing called a champion label. And what that really means is basically someone from the language design team has said, this is worth talking about. Like this is worth taking to that broader meeting and giving kind of the feature its day in court, so to speak. It doesn't even mean that the language design member necessarily thinks it's a great idea. It just means that they think it's worth having the discussion about. Over the time, I've actually championed several issues where I was like, I don't think we should do this issue in particular, but I think this issue is solving a very interesting problem. And I think we should discuss it and talk about it just so we kind of broaden our horizons and maybe find something else that we want to do as a result. So once we get kind of the initial proposal, though, we start by uploading what we call like a speclet to C#Lang. So if you've ever actually opened up like the C# language design spec, the speclets we upload there are generally not going to be to that level of detail. Instead, it's more of kind of a detailed overview of the feature that allows us to discuss its merits. It has usually a list of open design discussions, the higher points of how expressions should be bound, and things like that. And LDM, we discuss and we either accept or reject proposals. And when we accept proposals, it's really not a commitment that we're going to implement the feature. Accepting is basically a signal that says, this is worth putting more resources into. This is worth maybe go do a prototype. Maybe we had some questions about how this is going to work out in the lower level binding layers, or we have some questions about how many ambiguities it puts into parsing. And we should maybe go invest in like a 2 or 3 week prototype to see if we can get past those problems. Or we accept and say, this design we like the idea, but it needs a lot of work. So we kind of tentatively say, we think we can make this work and we're going to accept it, but kind of we need another meeting or two to really kind of hone in on the details here. But overall, what it means by accepting a proposal is this is an appropriate direction for the language. This is something that we think we should be doing. Lastly, though, we have to end up prioritizing it against other features, and we'll talk a little bit about that later. So the way we kind of make decisions in language design, though, is it's mostly a consensus building process. It's a very open discussion format. The kind of rules around the discussion have changed a little bit over the years. It turns out compiler people, we really like rules and processes, and that follows into our meetings, and we've had very strict rules before. But Teams have actually made our discussions a lot more structured, especially since Teams has introduced things like hand raising and voting and things like that. It's really kind of allowed us to make a lot of progress there. I forgot. Couldn't remember if I had one more slide there or not. Overall, though, it is a consensus building process. We spend a lot of time just basically discussing, making sure that everyone understands kind of the various kind of pros and cons of every decision that we're making. I could probably count on one hand in the 10 years I've been in language design, the number of times that Mads, the leader of language design, has basically said made an executive decision. And pretty much every other case, what we've done is gotten to the point where the majority of the people in the room have kind of think the language should go one way, and the others the other kind of side of the room, while they don't necessarily agree that that was the right decision, they don't think it's like a wrong decision. They're like, they would have preferred another approach, but they understand kind of the pros and cons, and they all agree kind of like, this will work, this will make a good feature. I wish we'd done it another way, but I understand why we made that decision. And that's kind of generally how decisions are made in our meetings. And lastly, like, how do we prioritize? Like, how do we pick from all of these ideas and actually decide, like, what are we going to ship? So we are not lacking for proposals. The community and our partner teams, they provide us ample ideas. And just even triaging through all of these ideas takes a significant amount of time, much less, you know, getting past triage. We have to get the real proposals and really have to debate the like detailed merits of these ideas. And as I talked about before, like, C# language design accepts proposals, and that doesn't mean that we're going to necessarily do them. And sometimes that just comes down to the fact that we don't have enough resources. Like, we have a limited dev team, and they have limited time in which to code and ship these features. Generally, our window for writing features and getting into language is about 6 months when you really look at the calendar. And really, many of these ideas are really compelling, and they solve really, you know, very real problems. But at the end of the day, like, how do we decide between good ideas? Like, a concrete problem we had in C#9 was we could either do param span of t. So if you ever use params of an array, param span of t is a way of doing that with a lot more kind of efficiency in how we allocate the call sites. Or we could do target type new, which is where you could just do the new expression now without types. And we had a choice in C#9, like, how do we choose between these two features? So, and to understand like how we make these decisions, I think it helps to understand like language design at a 1-year level. Because C# is now really tied to the .NET framework, and the .NET framework is releasing about once a year, C# is now in this 1-year cadence of releasing features. So starting with kind of C#7 through 8 and 9, pretty much every fall, you're going to see a new release of C# and .NET. And so at the beginning of the year, we kind of start the huge set of proposals out there, some that kind of fell through the cracks in the last release. We triage through them until we've kind of we've gotten through all the proposals and kind of accepted a set of ideas. And so once we've kind of gone through all those proposals and accepted a subset of them, we kind of take a step back and we go back to that first section I talked about themes. And we say, what themes are developing for this release? Like, it turns out like, hey, about 5 of these proposals we kind of accepted, like, they're really in that productivity bucket, or they're really in kind of the performance bucket. And so then we kind of step back and say, we would really like to kind of build on top of that. And we say that, okay, we know we're going to ship like these 5 things, and they fall into these 2 different buckets. And we have a whole host of ideas left. We start to prioritize the ones that kind of fit into those existing themes. Like, if we have a big performance theme, it's like, okay, let's get some more performance work in there. If we're doing productivity, like, let's make productivity better in this release. Like, let's really double down on that. And you can really see that if you kind of go back through the history of C#. So if you go back to C#6, there was a definite theme there. It was called ship. So C#6 is where we went from the old native C++ compiler code base to the C# compiler written in C#. And the theme for that release was actually shipping the product. It turns out if you take a language for 10 years, you give it to millions of customers and they write how many lines of code, there are a lot of compat bugs that you have to put into a new code base, and getting that right takes a lot of work. And so really the thing that we tried to do in C#6 was ship, as well as kind of deliver on our promise for compilers as an API, giving customers the ability to write analyzers or kind of like new IDE refactoring experiences. Yes, and that's pretty much all we did for C#6. For C#7, though, if you really look at it, like, there were 2 big themes we had with those releases. The first was productivity. That was when we gave people tuples, local functions, and we really kind of started to kick off our pattern matching, our series of pattern matching features that we've actually been building on ever since then. And we also had a huge performance bin there. So that's when we added ref structs, ref returns, ref read only, and kind of like read only structs. Okay. All right. So C#8, this is one where, as you'll see, we kept the productivity theme, because you're going to get that in pretty much every release of C#. This is where we started adding nullable reference types, and we really started to kind of evolve pattern matching even further. But we flipped gears a little bit, and we did a bunch of division initiatives. This is where we got like default interface methods. We got indexes and ranges. And then in C#9, we kind of flipped again. We went back to productivity and performance. Like this, we added records, top-level statements, source generators, and then we really hit that performance bucket again, where we gave function pointers, native size integers, and module initializers. And kind of looking towards C#10, there are a number of potential things we're looking at. One is productivity again. We're looking at kind of expanding records past what we did in C#9. As well as doing like static interface constraints. So this is where we could have like I arithmetic of t, and we could start doing math and generics again, as well as performance with interpolated strings and params, as well as we have kind of this division initiative we're on right now about kind of reducing ceremony in programs. Like if you look at a C# program like Hello World, where the goal is to print Hello World, you have if you do like a file new program, it's about a 20-line program, of which one of them is an actual functional line of code. The rest of it is a series of using statements, like namespaces, a whole bunch of things that aren't really like there to hit your goal. And so there's a big kind of push on, can we reduce the ceremony of C# and get it to where the keystrokes you write are more valuable? They're more about the actual code that you're writing versus all the ceremony that's kind of built up in C# over the years. And we have a number of things we're working on to really kind of reduce that. So like global usings, file scope namespaces, and we're doing a lot of work with kind of the rough edges of lambdas in C#. But with all that, like we have the typical prioritization problems with any team. Like the compiler team that I run, we have other responsibilities. So in addition to trying to implement the C# language, like we do compiler features like analyzers and source generators. We also do a lot of work to help out the Visual Studio experience. Like a good example of that is anyone who's used editor config in the last few releases of Visual Studio. This is something which is very much an IDE experience. Like editor config helps define and enforce code styles in an application. So you interact within Visual Studio, you get all these nice tool tips on how to reformat your code. You get warnings when you violate the code style and what have you. While that experience is very Visual Studio driven, the implementation is actually pretty much all in the compiler. Like it is very much a compiler driven feature because it's all about looking at code and producing warnings, which is really what the compiler team does. We look at your code and we tell you everything that's wrong with it. We very rarely actually compile binaries. Like that's a rare success story for us. Most of the time we're just telling you what you did wrong. As well as we also have a lot of infrastructure that we run. The Roslyn repository, where the C# compiler and IDE team lives, is a big repository. It's about 5 million lines of code. We have a lot of tests we run about 1 million tests on every PR. We validate the compiler about 3 ways from Sunday. And we actually have to do a lot of other infrastructure work to insert the Visual Studio. And it's a pretty significant cost on the team. And on the plus side, the community is actually increasingly helping us out here by contributing features into both the language and the compiler. But even when we get that community contribution, it actually still costs us resources. Like we have to spend time to basically say that we're going to commit to reviewing a feature, that we're going to make sure that they wrote the right amount of tests, help them work through some kind of troubling design counterpoints. It's a net win for sure. Like we absolutely get more than we pay for there. But it's still, the compiler team is a limited resource, and we have to be kind of like prioritize like how and what we are going to spend time on. So that kind of is kind of the end of the talk there. And so wanted to kind of like open it up for people to ask questions, comments, whatever. Yeah. I don't know what how you all structure Q&A. So however you all do that, I'm happy with.
Oh, pretty much like that. So I mean, are there any questions?
Did they show up in like the chat or the chat?
Sometimes they will. Sometimes people will come off mute.
Oh, either way, it's fine with me. All right.
Well, I mean, while we're waiting for others to ask, that Discord. So that was a public Discord server.
Yes. I will.
Do you happen to have the link for that?
I do somewhere. Give me just a second. I'll drop it in the chat because we have it on our Roslyn repository.
Cool. So there's a question on Twitch. The question was, what's the best way to contribute?
So the best way to contribute, well, it depends on what you're trying to contribute. So the best ways to our GitHub repo. So github.com/net/Roslyn. So there are a number of different ways to contribute. The first is like, I tell people it's like, some people are like, oh, like, it's a big code base, and it is. Like the Roslyn repository, it's about 5 million lines of code last time I counted. So if you've never been in a like a big code base before, like it can be intimidating, and we understand that. And we do our best to make it as easy as possible. We do things like we have the help wanted issues. So definitely look for help wanted issues on the repository. Those are issues that we feel require the kind of like you can kind of have like very focused small bug fixes and not have to really kind of deeply understand the giant code base you're working in. We also try to stop our own developers from fixing those issues. If it's a big bug, we'll tell them they can fix it kind of when we get close to release. But generally, we tell our developers don't touch help wanted issues because we want to reserve them for people who are trying to get into our code base and start building up kind of their skills and contributing. So that's one way, is just simple bug fixes. Another way is filing bugs. Like if you hit what you think is a bug in the compiler, like file an issue on the repository. Like we're happy to help out. We're happy to talk to you about it. And also if you're trying to, like, we also have lots of documentation gaps. As much time as we spend on documentation, we could always use more. And I always encourage people, they'll say like, oh, I try to contribute, but I hit this bug. And we kind of work through them like, oh yeah, sorry, we didn't realize that your machine had this, like tweak this and you should be able to build and contribute just fine. And one of the things, if we ever have that interaction with you, is send a pull request, like help us fix our docs to like work around whatever problem you hit. Also, just if you're interested in the language, come to the Discord channel, chat with us. Like it's a fun little community. The Discord is very vibrant. I at times try to spend a lot of time in the Discord and interacting with customers, but it can actually be so like daunting. The amount of chatter that can go through in between like 2 meetings that I go through can almost take me a good like 20, 30 minutes to catch up on. But it's a very vibrant group of people. It's a very fun thing to participate in. So I'd say that like one way to get involved is just drop in the Discord, start chatting with people, see what people are working on, where they need help with things.
Hey, can you hear me?
Look.
Yeah, thank you for the great presentation. It was nice seeing how it works on especially from the core team of the C#. But my question is kind of off the topic. But if you had an interview question, sorry to steal your C#.
Yeah.
But if you had a like top 2 C# question in order to have the interview, what would it be?
So interviewing, it depends a lot. Like, so I've interviewed a lot of people over the year. I do a lot of work with interviewing. And I'm actually someone who spends, I rarely interview the same people, 2 different people the same way. Especially nowadays, like I like looking through people's resume. I like trying to look up past work that they've done. I like trying to like find things out about them so that I can have like a nice conversation with them when they're there. My interview questions are generally very boring. My coding interview questions, like for my, and I've said this plenty of times, so it's, anyone who looks it up can see it, but like my typical college interview question is, I ask people, write a function that takes in a series of letters and tell me if there are any duplicates. Because I like questions that don't have one answer. I like questions that have a variety of answers, because I like to basically take my interviews and basically I like to make them very easy to answer. And then no matter what answer you choose, there's always a way to have fun with it. So the easiest way to say like, oh, does this series of letters have a dupe? Is like, well, just create a hash table, just throw them in there and see if you have any, if anything's already in there, return. It's like, that's an absolutely acceptable answer. And then my response to that is usually, great, you've used a hash table. Well, it turns out that allocating memory is like super bad in this scenario. Like we really can't allocate memory. Like that's bad. Like how would you do without allocating memory? And it's like, I like to take conversations in that direction. So I have some kind of like binary tree questions I ask like kind of more senior people, but yeah, like that. I don't like hard, tricky interview questions. I like easy ones that have lots of answers, because you can have a lot of conversations and kind of ask, you can change the parameters as you go, just to see how people can adapt their solutions along the way, because I find that's more reflective of real world scenarios. It's rarely go out and implement code. It's like, oh crap, I implemented that, but turns out allocations are really bad there. It's really spinning the IDE off into a pit. We need to find a way to do that with this. We need to move the allocations from here to here, or we need to, push IO in a different direction. So that's the type of thing that I like to ask.
Definitely. Thank you. Thank you.
So another question from Twitch. Can you point to documentation that we can get started with reporting bugs and or contribute with bug fixing?
I'm really trying to find the chat here, and I am failing. There it is. There we go. So,
well, the one I'm reading here is actually on Twitch.
Okay. So that is the Discord link, and overall, this is the Rosin repository. This is where the C# team. There we go.
So kind of building off of that interview question, I thought that was actually kind of fascinating. What special kinds of considerations do you give when interviewing somebody for the language team? What sort of things are you looking for?
So in order to work on the compiler, so there's one kind of difference. Like I run the compiler team, so the language team is actually like it's not a real team. The language team is like everyone who participates in the C# language design like has a different job. It's just that like one of the things they do is they're on the language design team. The team, which is actually like has a boss, me, and people who actually like are just there to work on, is the compiler team. So I'm generally interviewing people for the compiler team. And there's a good overlap. I think about half the people who work for me are also full-time members of the language design team. They all go to the meetings when their features are being discussed, but half of my team is in all of the meetings. And so in order to be on my team, you need to have like 10 years as a compiler developer on a top-notch. No, that's nonsense. There are very few production languages out there that are funded by companies. So you probably, if you look at all the languages out there you use, I mean, there's probably, you probably say like Rust, Go, C#, Java, C++. You could probably, maybe if you really like worked at it, like double it and say like, okay, there's 10 languages out there that are funded by a number of companies. And if you say all of them have 8 people on it, you could say, okay, great. That means there's 80 people in the world that would meet even the qualification of have worked on a production compiler before. The reality is like when we hire people in, like you're not going to have the chance that you're going to get someone who's actually worked on a compiler before is super rare. Just because when people join compiler teams, they tend to never leave. Some of the people who've been on my team have been on the compiler teams for like 14 years. So generally when you're interviewing people for the team, it's people who have never worked on a compiler before. The things I tend to look for though, is I tend to look for people who have worked in any kind of developer tooling before. Like if you ever had a customer, you ever build a product that you're giving to other developers, because that's what you do in a compiler, like you're working with that. I like people who've worked on any kind of system level programming. A compiler is it's a system level tool. It's a language. That's the only thing special about it. We take a text file and we produce errors. Every now and then we write a binary to disk. I mean, people who come from giant code bases is a plus because, like I said, it's about 5 million lines of code. We have everything from the compiler all the way up to edit and continue from Visual Studio. So it's a huge code base. People who've worked in big code bases, it's a big plus. I also spend a lot of time talking to people about kind of the reality of the compiler. The compiler, like our number one feature that we have in C# is backwards compatibility. Like you can upgrade it every time you upgrade Visual Studio, your code's going to keep compiling and it's going to keep running like it did the time before. We put a huge amount of effort in making sure that we maintain that invariant and make it easy for people to get new versions of Visual Studio. And so like I've had people who want to work on my team before, and they are kind of like, people who are like, I want to move fast and break things. And it's like, you will not be happy here. We do not break things. And when we break things, like we feel very, very bad about it. And we take great pains to never do that. And so I spend a lot of time talking to them about like, you're just not going to be happy on the team with that kind of attitude, because that's just not what we do. Also, if you can sit through a 2-hour meeting on like a deeply like boring, like a deeply detailed, like mundane spec and not fall asleep, that's a big plus. Those are things that we have to do. So yeah, so those are the kind of things I look for. It's just like practical things. Compilers are a systems programming tool that you give to developers. I like to look for people who have similar types of experiences. Because I feel like if you have those experiences, teaching you how to write a compiler is usually like we're pretty good at doing that these days. Teaching someone how to be a better language designer, that is a little bit more difficult. I'm not sure what the best way to do that is. It's more keep putting you in the environment and hopefully you'll figure it out. It's more like art to a degree. I think I did it for about 10 years before I was mildly competent.
Basically, just somehow get rubbing off from Anders and Mads.
Yeah. Yeah, all the times Mads told me, Jared, that's a terrible idea. We're not going to do that.
Yeah, I like that, taking text files and producing errors. That's pretty much what my job is, except I start with the Jira card and then I produce bugs.
Yeah. And I think so. I joke, but it is true. So one of the most interesting things, like I think people don't realize until you actually work on the compiler team, is code. If you look at like all our code is basically used to take text, produce diagnostics, write a binary to disk. The overwhelming majority of time the compiler API is invoked, it produces errors and does not produce binaries. And the reason why is because most people I think probably tend to think of build, and they're like, well, my build succeeds a lot more than it fails because I run in CI, I run like all these different outer loops. It's like, that's absolutely true. But do you type in Visual Studio? Like every keystroke you type, they essentially run the compiler on. Like as you type in Visual Studio, like if you pause for, I think it's about like half a second, they produce diagnostics and tell you, oh, you're missing a brace. And so like when you think about like just the act of typing out a program, the compiler produces diagnostics for every keystroke roughly. And so that means the majority of the time the compiler is run, it's on a completely nonsense incomplete program. And so one of our biggest perf challenges is how can we produce errors as fast as possible? How can we parse that code and give them those errors, give that IDE team those errors as quick as we can do? Like that is literally one of our like biggest challenges, is like producing errors really quickly for the IDE team. Successful compilations, that's boring. That happens like 1% of the time.
It's actually kind of interesting to think about that.
Oh, from the chat. Is that why VS runs so slow for me? I also run VI Emu. I wrote VisVim. You should use VisVim. That's your problem. So not only am I a hopeless compiler developer, I'm also a hopeless like Vim addict to the point I wrote a plugin to Visual Studio for it. So.
So there's also another question here in chat. Basically, they're saying that they're very new to C#, and they're asking if the Discord channel was a good place for code newbies like themselves.
Absolutely. The Discord channel. If you go to the Discord server, it actually has a number of different channels. It has everything from like kind of like they have like there's a series of kind of like general Q&A chat rooms, and I say a series because they actually found when they only had like one Q&A chat room, it just got so much text with scrolling. They said, no, let's have like 3 or 4 chat rooms so we can like move people between them and kind of keep the conversation more coherent. They have like kind of beginners channels, people who are learning the language, people who are interested in very strange corners of languages. Like they have kind of a Windows, a Linux room. They also have rooms, or I can't remember if Discord uses like channels or rooms, whatever their parlance is, but they have rooms for like people who are really into performance, people who are into language design, or people who are writing kind of like analyzers or generators for Roslyn and need specific help on that. So the Discord is absolutely a great place to go, period, for C#. And they have all manner of kind of like channels for you to kind of participate in. Oh, the Discord invite is expired? I will fix that. It's Tanner's fault.
That worked for me. I took the last.
I have to see. Huh. Might want to try it again because it's opening Discord now. Yeah. any other questions, like features you want to ask about? Features are like, oh, I really wish you would do this in the language, or like, why did you do that? Like any of those questions, fair game, anything.
Do you ever get people complaining a lot where sometimes it just becomes overload where with all the helpers and everything as you're in the editor and compiling, where you want some of them, but you don't want, you don't want it to where it's interrupting your flow.
Yeah, we definitely had a lot of so that's definitely something that's come up before about one thing that we call, there's a term we use, we call it like the warning wall. It's like if we do this feature, if we added this feature in the language, would the user just get like a wall of warnings when they turned on this feature? And it's something we talked about a lot with kind of with the influx of analyzers and code styles and things like that. Like how do we make the warnings manageable for users? And one of the things is if you look at editor config, is that was designed and put in Visual Studio to kind of make it easier. It was done. Basically, it's a way to essentially very easy and categorically take entire classes of errors and just warnings, and basically say, I just don't want to see them anymore. And Visual Studio, if you get the more recent releases, they're actually really honed into that system now. And you can actually, when you get certain types of warnings, you can do the drop down and say suppress an editor config, and it will just drop it from the rest of your entire solution. But we do get that feedback. And if you have a particular one which is causing you too many problems and it's not solved by kind of either the editor config suppressions or other things like that, post an issue on Roslyn or ask on the Discord, and someone will definitely help you out and get you sorted with that.
Okay, cool. And that actually just helped me with one right there, because I've gotten and I'm probably a lot of people have it, is you become so kind of just immune to the fact that they're there. I didn't even know there was a suppress there. I'll have to check that out.
You compile your code with warnings?
No, well, no, there's no warnings, but just too many helpers. So you kind of,
Yeah. That's the only problem we've had. It's also been very fun because we eat our own dog food, and so we really rapidly use our new tools. And when we have bugs that are over suggestive, it can be fun for the IE experience for us.
Yeah, I can imagine. Thanks.
Yeah, so you invited us to geek out on language features. I'll funnel one of my team members who is a big fan of Kotlin. I'll challenge him, and so he was asking me about something you can do in Kotlin. How do you do this in C#? And we kind of figured it out. Basically, it's you've got a conditional statement. You've determined that a variable is not null, and now you want to be able to use it. And so he was telling me, I haven't tried it myself, that in Kotlin, the compiler now knows from this point forward it's not null. But using pattern matching, I had to define a new variable name for it.
In general, so if you're talking about nullable reference types, in general, that is supposed to work. When you do what we consider a pure null test on something, then after that point in the program, we will generally consider it non-null and pull out all of the warnings. Now, the problem is that is a test for something non-null it's a bit of a heuristic. You can look and say okay, they used equals null, but they have a custom operator there. So we called into random user code. Did that code actually validate if it was null or not? We have a heuristic. We're if you wrote an equal operator, you probably actually checked null for null. So there are kind of corners the heuristic can fall into certain places where we will have to basically say we can't be 100. It hasn't met our criteria for not null, and so we continue to give the warning. But if you post one of those examples, if you throw it on GitHub or something like that later, we can either talk you through either it's a bug or if it's by design or what have you. But in general, that's the way the language is meant to work. The nullable reference type feature is specifically designed to look at the flow of your program and say, okay, they tested for this here. That means going forward, this can't be null. Or once they've invoked a member on it, it's well, if it was null, it would have thrown on that line. So going forward, we should assume it's non-null from this point out. So we have a lot of, that's how the feature is supposed to work. So if it's not working that way, we like to hear about it. There are a couple of places in the language where we've said we won't track that type of check. So it could be you're hitting a design issue, but if it is, I'd still like to kind of tell you about it and tell you about what kind of the alternatives we tell people to go to instead of the patterns we don't support.
Okay, yeah, I have to track that down and see exactly what it was that was causing that not to work. It might have been testing instance of a type rather than null. But yeah, I'll see if we can find that code, and then I'll bring it back up in Discord or
Okay.
one of the other things.
So, what recently has caused the most issue on your team as far as features to get it implemented?
What has caused us the most like headache?
Yeah.
What to choose from? So one of the kind of records is an interesting one. So records, records are fun because they are types which are kind of defaults to immutable. So when you do like a new record in C#, if you say like record point of int x and y, what you've done is create a class which cannot be mutated. However, we have this thing called a with expression with records because we want to make them usable. So you can say basically you can create a new record, which is immutable, but you're like, I want to change one property on that record. I want to like take everything that's in the record. I want to change one or two of the properties. So what you can do is you can say like point with, and you just open up a new object initializer, and you just set all the values as you would with any other object initializer. And under the hood, what we're doing is we allocate a new copy of the point. We copy all the old values over, and then we just change the new values that you've added in, and we return that new object. So whenever you do like kind of a new record, you do a with expression, at the end of the day, you end up with two different objects. What caused us no end of pain and suffering was figuring out how to copy the properties from one object to another. And that's because records can span class hierarchies. And so when you are basically doing like a point with expression, if you're saying, hey, I'm about to create a new instance of this object and copy all the properties over, one thing you have to spend a lot of time thinking about is, what if it's an unsealed type? There might be, like, I might be looking at a base type. This point might actually be a 3D point, and I'm only looking at it from the 2D point interface. And so how do you maintain that invariant of width is only going to change the exact property you say it's going to change when you could be dealing with an invisible class hierarchy? And so the way that we had to implement code generation for records had to deal with all of the problems that could come up there about how do we basically have essentially virtual constructors? Because what we really wanted to say is we want to create a new instance of this object based on the exact type, which you would kind of say, oh, I want to use a virtual method. Whenever I want to like peek through a class hierarchy and have specific behavior, I want to use a virtual method. But you really wanted a constructor. And how do you basically have a virtual constructor? And that caused us months and months of like head to desk. Like, how do we make this work in C# and how do we work it across a couple of languages? And the good news is it actually came out with a couple of different features, like a init-only setters is something that came out of all of that work. And that was kind of an implementation detail of how we built up with expressions. Trying to think of a silly one that we've spent like how Tostring works in records. So if you have a record is just a series of values. It's like record, point like int x, y. If you do Tostring on it, you'll see it's this very nice printed thing. It will say like, what is the name of the property equals what is the value, comma, what is the name of the second property, what is the value. How we put those commas into that string was a considerable amount of design point for us, because we wanted Tostring to be customizable by users. We wanted customers to be able to say, hey, I want to customize how a few of these members are printed in the string. And so we had to devise kind of this method where we created a string builder. We called print members for a couple of the members. We passed the builder down. Like, did the customer insert the comma or do we insert the comma? Like, when do we put the comma in and how do we deal with that? We had like, I think 2 full design meetings on how to get a comma into that string correctly. To the point where it was just like, really, we're trying to figure out how to put a comma in a string. But when you start dealing with how we let customers customize the record types and override Tostring and override hash code, we do have to spend a lot of time thinking about all the ways it could be done and how do we design it so that they do it towards the pit of success instead of the pit of failure.
There's a question on Twitch. Why even bother implementing inheritance for records?
Why do it? It's because we found that a lot of people wanted it. Like, in some ways, like records is an easy feature. Like you can go to pretty much any functional language out there and they have records. Like there's no design decisions to make. Like one thing I joked a few times, if we didn't care about inheritance, we just, F# on records, like make all the same decisions they make, move on. At the end of the day though, like C# is a language that supports inheritance. It's something our users use a lot. And when we were kind of looking at teams who had come to us before and said, we want you to do records because we want to remove a lot of this boilerplate code, we looked at their scenarios and we kind of looked through them and we're like, this feature won't be successful unless we solve inheritance. Because if we don't solve inheritance, they can only use it in this very small section of their application. They can't use it in this much broader scenarios where they want them to be used. And so we decided, we placed a lot of value on making sure that we could solve that and making sure that it could work with a good bevy of C# features. I mean, the other problem is if you don't support records, it means it can sometimes be hard to evolve your code, because a common thing that we find customers do is they start with a type, and then later on, as they kind of evolve their application, they say, well, now I need to put a base type here. I need a base type to kind of like add some new functionality, add a new drive type, and start pushing it through other places. And so if we couldn't solve inheritance, we didn't feel like it was going to be a complete solution for C#. And believe me, there were times I wish we decided that was a bad idea, because the amount of hoops we had to go through to solve that was very difficult.
Awesome. So anyone else have any other questions? Let's see here. There's a question. When using discards with tasks, why are all errors suppressed?
Probably need to see that one in more detail, because I'm not quite sure what you're referring to there. If you have more detail with that one, like if you want to like follow up later and like put some code in, I can definitely like follow up with an answer there. But in general, errors are never suppressed. They can't be. So I'm not quite sure what you're referring to there.
All right, any other questions?
Yeah, do you ever wish that that C# was just a small, simple, constrained language? I mean, is there something in C# that you wish it just wasn't there?
We get that all the time, and I think that people like I think we get that all the time, and like customers are like, oh, it'd be so much better if you like you didn't have this in the language, or you didn't have that in the language, and it's like, what I would remove? I wish we never allowed underscores as an identifier, because discards would have been a much better feature if we never allowed underscores as an identifier. Like those are the things I like worry about. And I think like I know some people look at they tend to like I think people tend to look at the language through kind of their usage of it and like what they find valuable. And like one of the things I kind of said in the talk is like a lot of people will tell me like, dynamic added some baggage to the language and complication. It's like, you're probably not a customer who uses dynamic then. It's like dynamic is something that a lot of our customers use a ton. And as kind of the compiler lead and someone who's been on the team for 10 years, like I spend a lot of time talking to customers. I spend a lot of time like working through bugs they filed, things they've used. And what we find is like pretty much everything we've written is used by customers somewhere. And really, when we talk about evolving the existing features, they very rarely hold us back from evolving the language. And maintaining those old features is actually not a ton of work. There's occasionally a case like when we do a big feature like nullable reference types that we regretted some features that we'd added in the past because we had to rationalize that feature with everything that was in the language for 20 years before that. But for the most part, like if we add a new expression, it just has to work with other expressions. Like we don't have to like completely revisit dynamic every time we add something. We don't have to revisit, pretty much any like feature in depth when we add new ones. Like we have to like make sure they interact together. But the maintenance of them very rarely holds us back. So we rarely run into scenarios where we're like, man, I wish we hadn't done this. what ends up holding us back is like often like very obscure things I think customers would never really think of. Like when we first did pattern matching, Neil Gaffner, who is an insanely smart person, he had like scoped pattern matching out. He had like the full like 5-year plan for how we're going to do it. And then he got befuddled when he went to implement it because he found out that when you do a switch case statement, whoever designed that like 10 years ago added all these implicit conversions. So if you have like, for instance, like an int in a switch case statement and you have a bunch of cases on long literals, they will attempt to convert that to a long ahead of time. And that means that we call into user-defined operators. And that broke everything that Neil wanted to do with pattern matching. And we had no idea that existed until we went to implement the code. And so we really, for 2 weeks, super regretted that little tiny, tiny decision. But we didn't regret switch statements. We still wanted those. But things like that, those tiny little things like having covariant arrays, like that has been us several times in features we wanted to do. But I bet the kind of average user probably wouldn't point to that. So the things we regret, there are things we regret, but it tends to be kind of in the smaller. Probably the biggest thing that I would say we kind of like causes me the most recurring pain is how we do type inference. Type inference is an incredibly involved problem in C#. It is computationally expensive, and particularly when you combine lambdas and type inference together, it is an NP-complete problem with overload resolution. And I wish that they had found a better way to do that, because that would save us a lot of pain in some of our features.
All right, anyone else have anything?
Yes, I have a question. I occasionally will try to read some of those computer science papers. I really want to be able to read them, but I find them too dense usually. How much formal computer science would you say you guys have to read to implement the compiler?
So I will give you a kind of counter story to that. So I am technically a published research paper author. That is because I had a PhD intern when I was working on Midori, which was a C# research project, and they wrote a paper that was accepted into OOPSLA about how we'd done some immutability and permission modeling in the language. This is a feature I designed, I implemented, I pushed through an entire like operating system and whatever code base. He wrote the paper, and then he got to read it to me, because when I started reading it, I couldn't understand what the hell it said. So I could understand, like, generally, if you look at academic papers, they tend to be broken up into a couple of sections. Kind of the first section is kind of like the intro to the problem. Then they have kind of a functional overview of what they did. Like, okay, like here's the problem. Here's kind of like how we approach the problem. And then what they have, I generally refer to as the Greek. The whole section where they attempt to prove that their problem is correct. I couldn't read it if you put a gun to my head. Like I remember, like when they were submitting this for formal, like for a research paper, they literally like came and like, what do you think of the proof? And I'm like, you're gonna have to read it to me. And they would read me the proof, and when they verbalize, I'd be like, well, I think you should say it like kind of like this, not like that. And they write down some more Greek symbols, and they were like, how does that look? And I'm like, read it to me. Like I can't read this. So in terms of formalization, like no, like I don't know. There's only one person who's worked, two people who have worked for me over the years, who could actually read the Greek and like tell us about it. And one of them was Neil Gaffner, and one of them was like Andy Goki. And they were two people who were very kind of academic leaning. And then also in terms of like just straight up like academia, like how much computer science academia do you need in order to join the team? So I will tell you that I went to college, majored in computer science. I did not major in compilers. I majored in networking and operating systems. I TA'd the intro to compiler class, and I hated compilers so much. I did not take the higher level compilers courses. When I started at Microsoft, back in the day, they gave you this like sheet, and they're like, check all of your interests, like put a check mark. I found compilers and made sure I did not check that box. I checked every other box besides web development compilers, because I did not want to work on a compiler team. So that's how much academic experience I had with compilers, not a ton. So it's helpful in some cases, but I find that most people who can like work in systems level programming, you can generally work through the first half of those research papers and kind of get the gist. Okay, like this is the problem they're solving. This is the kind of approach they took. then they get to the Greek and the proofs, and then it's like, you don't need that.
I love that the two you picked was compilers and web development, right?
Yeah, because I was like, I'm not good at that. Like I tried that a few times. Like, no, I don't do that. No, I actually, I like the only reasons I work on the compiler team is literally the first group I joined at Microsoft. I could not empathize with the product, and I could not empathize with the customer. It was very abstract for me. And my boss moved from our current team. She went to work back on the compilers team. And I was like, well, I know what a compiler is. I know who the customer is. And I liked working for Julia. So I'm going to go over there because maybe I'll be happier. And it turned out that production compilers were a lot different than academic compilers. And I was a much happier person over there. So someone put on the chat, like, do you ever meet with other language design teams at Microsoft? Like, definitely. I spend a lot of time working with, particularly, I talk with the C++ team, like Herb Suter. I talk with him regularly about things that he's doing in C++. Microsoft recently started a Rust team that's run by some former coworker of mine. I talk with them a lot. TypeScript is someone we communicate with a lot, particularly if you've used C# nullable reference types and you've used TypeScript nullable reference types, you'll probably find out that there's a lot of similarities between those two ideas, and that is not a coincidence. The F# team as well, Don Syme, pre-COVID days, whenever Don Syme was in town, I'd always find a way to have some time with Don and chat with him about what was going on in F# and what was going on in C#. Super fantastic guy to talk to. So yeah, spent a lot of time talking with other language design teams around Microsoft. And we actually end up, and back in the days we could go to conferences, we would try to meet with language design teams from other companies. Like some of the Java people from Oracle and some other places were really fun to talk to. So for someone who's like new to languages, what would you focus on learning? The thing I always tell people is like, if you want to get good at programming languages, I tell people it's like, find one language, like probably the language, like either if you're in school, like look at your course schedule for the next 2-3 years. What language are you going to do the most coding in? Or, if you have a job, like what language are you using on your job? Get really, really good at that language. Like spend some time learning all of the quirks of that language. I love to look up like what are the quirks. Like when I started learning Python, it's like I Google like quirks of Python and start like what are the kind of funny corners that Python can get into. But get really, really good at one language to where you can really understand. You could understand the breadth of the languages, the strengths of the languages, and the weakness of the languages. And then take 1 or 2 other languages and just become like moderately competent in them, so that you can understand how to take the concepts that you're extremely good at in one language, and you can apply some of them to another language. Because I feel like you're a programmer, like languages, it's what you're going to work with every day. And once you become extremely good in one, and you kind of understand 1 or 2 other languages, I feel like that unlocks all of the levels for you, because it lets you kind of see the underlying concepts, it lets you see how they work elsewhere, and it gives you a bit of intuition about how other frameworks and languages you approach are also going to work.
And yeah, C# is the prominent language here in this, not just in Louisville, but really most of this part of the country. C# is the prominent language. Not to say there's no other. I mean, there's Java's not. I mean, here in Louisville, Java is not used very much, to the point I can pretty much name you all the companies that do Java. But I mean, to Jacob's questions, I mean, there are other languages here in this area. But yeah, C#, especially for the bigger companies, C# is definitely the.
F# is better. I was actually just going to say, Alex said F# is better. I will tell you, like, if you are looking to expand your horizons, and you are a C# developer, I would absolutely say, like, what you should do is like pick up an F# book. And so F#, if you're unfamiliar, it's a functional language that is written on top of the .NET ecosystem. Anyone who knows functional languages, it's really just OCaml on top of .NET. That's really what it is. But functional C# is kind of an object-oriented procedural language. It's a grab bag of languages, but it's kind of its roots are in procedural programming and kind of an object-oriented programming. Functional programming is kind of like, it's still code, but it's a very different way of thinking about code. It's something that will kind of really force you to think about like union types, like pattern matching, thinking about things in terms of very discrete problems and things that can be solved with like very simple functions that you end up combining into bigger things. It will really expand your horizons as a programmer. Like even if you just pick up an F# book, you write some F# code, and you never have a job in F#, I feel like it will expand your horizons enough that will give you new ways to think about the code you're writing in C#. One of the best things I ever did in my career was learn F#, because I had no functional experiences when I was in college. And I just literally happened to be sitting down the hall from the F# team when they started at Microsoft. And one of the guys who was working on it, I went to college with, and I picked it up as kind of like a hobby project. And it really expanded my horizons and gave me kind of a new way of thinking about coding and a new way of approaching problem solving. And it has greatly influenced the way in which I write my C# code.
I wonder if you say the same thing for Python.
So Python is, so I have not spent as much time with Python. I've spent more time but in terms of kind of like dynamic languages that I've used, like I spent a lot of time hacking on PowerShell. I spent a lot of time hacking on like VB in the day and other like kind of more dynamic languages. They taught me how to think about a little more like unstructured data better, but like functional programming, but I felt like there was enough kind of like scripty things I'd done in my life between Perl, like did a lot of Perl in college, and PowerShell. Like Python was kind of, it's a dynamic, it's a great language, but it's dynamic, and that's kind of its core. And I had been doing a lot of that throughout the years. So when I learned Python, it didn't really kind of open my horizons to like thinking about problems. It's just like, okay, here's a better language for doing the things I used to be doing in other languages. But functional programming was something that I was like, oh, like this is actually a completely different way of approaching problems. And the language will really force you to break problems down in a different way. And it's not always the better way, even though Alex says it is, but it's a different way. And I think it will challenge the way you think about programming. And at the end of the day, it has lots of concepts about thinking of things like functionally, thinking of breaking things down as like callbacks and things like that I write in C# every day. So.
Thank you.
Yeah.
Talking of languages too, I just built my first Blazor app, which I'm really enjoying Blazor with C#. And I'm curious, is there a trend right now more towards the website versus the server side?
So I am not the best one to answer that question. I literally I actually this 6 months ago I actually started writing a website for some of our infrastructure problems just so I'd start learning how to write them because I work on compilers. I've done some WinForms UIs. Like I'm a tried and true like backend person, and so I am not the best one to answer that question by any stretch. I actually spent a lot more time recently learning kind of like Razor. Not so much Blazor. Blazor is kind of something I want to pick up probably in about 2 or 3 months when I start a new project. But I wish I was a good person to answer that, but I'm not.
Yeah, no, that's okay. I started with Razor, and then there was something I wanted to use a Blazor component in, and so I was just kind of getting into it. And I was, it's fascinating. It's been fascinating to listen to you talk in general because you don't think in terms of the team behind the compilers as much. When you're doing these, how many people are on your team?
So the team usually has it fluctuates a little bit. There are usually somewhere around 7 or 8 people reporting to me that work on the C# team. But yeah, so that's about that many.
Yeah, that's pretty fascinating for that. You'd think it'd be like a huge group of people, but
Yeah, it's, when you think about that's just the people who work on the compiler. When you think about the C# experience, so like the IDE team, so there's basically 2 other leads that kind of end up running the IDE team, and altogether we probably have about 20 people under us.
That's amazing.
Yeah, but they own everything from like how IntelliSense works to debugging to how to continue to the compilers to the languages. I also have a lot of fantastic people report to me. Like I said, I've been at Microsoft, I think 17 years. 3 of the people who report to me have worked at Microsoft longer than me, and 2 of them have been on the compiler team longer than me. So
That
it's
says a lot.
yeah. So some of them are really, really good. I have one guy who worked for me. He actually was my mentor when I joined the compiler team. I swear he remembers every line of code he's ever written. And whenever we have a bug, he will like come to us sometimes. He's like, oh, you know, that you're gonna hit that bug that we introduced like 10 years ago. And I'm just like, Jesus. So yeah. But
I have a hard enough time remembering the code I wrote earlier today.
yeah, I know it. That it's his name is Alexei, and he is a fantastic. Like I said, I'll go to him sometimes. I'm like, do you remember like 10 years ago we had that problem? What? And he's like, oh yeah, here's what you're thinking about. And I'm just like, oh, thank you. But no, it's a fantastic group of people. But it can be a challenging place to work in, because one of the things that I tell people who join the team, it's like it's an area that's very hard to become an expert in quickly, because there's 20 years of history. There's 20 years of like things we've done, bug fixes we've hit, and it takes time to kind of get that backlog of knowledge. And a lot of your early days is talking to people who've been there a while, being like, why did we do this? Why did we do that? Why did we do this? And getting a better kind of grasp of it all.
All right, awesome. So any other questions? All right, so I can wrap up the Twitch side, because I will say, a lot of times I'll see once we get off of Twitch, people start speaking up more. So everyone on Twitch, thank you for joining tonight. Really appreciate y'all coming on.